This is section 1.8, solving absolute value inequalities. So earlier in this unit, we talked about solving absolute value equations. And remember, we got the absolute value by itself and then had to write two different equations. Same thing is going to apply with inequalities. So we're going to have two inequalities, so it's going to become a compound inequality. So split, and you have to decide if it's going to be an or compound inequality. And then a trick to remember how you're going to decide is less than and greater than. So if it's a less than or equal to, it's going to be an and inequality. If it's a greater than or a greater or equal to, it's going to be an or. So let's look at this first example. So we have 4 times the absolute value of 2x minus 5 plus 1 is greater than 21. Just like with equations, what we want to do is we want to get the absolute value by itself. So we're going to subtract 1. 4 times the absolute value of 2x minus 5 is greater than 20. Divide both sides by 4. So the absolute value of 2x minus 5 is greater than 5. Since it's a greater than, it's going to be an or. So 2x minus 5 is greater than 5. Or 2x minus 5 is less than negative 5. So just how we switch this to be a negative, we're going to switch the inequality symbol to face the other way. And then we just solve. So I'm going to add 5 to both sides. 2x is greater than 10. Divide by 2. X is greater than 5. Or, so add 5 here, add 5. 2x is less than 0. Divide by 2. X is less than 0. And then we draw our number line. Here's 5, here's 0. They're both going to be open circles. Greater than 5 or less than 0. You can go ahead and test that by picking any number you want. Otherwise, just trust that you're doing it correctly. So let's look at the next one. So the next one is a lot simpler to start off with. So we have the absolute value of x plus 3 is greater than 8. The absolute value is already by itself, so we're good. It's a greater than, so it's an or. So x plus 3 has to be greater than 8, or x plus 3 has to be less than negative 8. Solve those. So x is greater than 5, or x is less than negative 11. Draw your line. Here's negative 11, here's 5. They're both open. Greater than 5, less than negative 11. All right, let's try another one. So we have the absolute value of n plus 2 minus 3 is greater than or equal to negative 6. Have to get the absolute value by itself, so we're going to add 3 to both sides. So the absolute value of n plus 2 has to be greater than or equal to negative 3. Notice that if it were an equation, if we had an equal sign, we would just give up right now because we can't have a negative. With an inequality, it's not necessarily going to be that way. So what we're going to do is we're just still going to split it up. So n plus 2 is greater than or equal to negative 3, or n plus 2 is less than or equal to positive 3. So go ahead and solve. N is greater than or equal to negative 5, or n is less than or equal to 1. Draw down our number line. Here's negative 5. Here's 1. both closed circles. Going this way for the -5, and we're going this way for 1. Notice how they overlap going in opposite directions. So in this case, all real numbers work. Which should make sense, because no matter what number we plug in for n, an absolute value is always going to be greater than a negative number. Okay? It doesn't matter what you put in for n, positive, negative, whatever. It's the absolute value of that number is always going to be greater than a negative. Notice that if this were flipped the other way to be a less than or equal to, this one would not work because you can never have an absolute value less than a negative. So it's still possible to get an infinite number of solutions, like all real numbers, or no solution is also possible. All right, and our last example here, we're going to take 3 times the absolute value of d plus 1 minus 7 is greater than or equal to -1. Add 7. 3 times the absolute value of d plus 1 is greater than or equal to 6. Divide by 3. Absolute value of d plus 1 is greater than or equal to 2. It's greater than, so it's an or. So d plus 1 is greater than or equal to 2, or d plus 1 is less than or equal to -2. Go ahead and solve. D is greater than or equal to 1, or d is less than or equal to -3. Go ahead and graph it. -3 and 1. Closed circle going to the right, and a closed circle going to the left. Very similar to equations like we talked about, but now it just becomes a compound inequality. So absolute deviation is, think about, when you talk about absolute deviation, think about manufactured goods. So if you get a bag of chips from the vending machine, odds are that it is not exactly the weight that is listed on the package. Usually what manufacturers do is they have a range of acceptable weights, just so it doesn't take forever for them to individually check every bag and make sure it's exactly the weight it's supposed to be. So we can represent this with absolute deviation in an absolute value. So the absolute deviation is equal to the absolute value of x minus the given value. Another way I like to put it is the absolute value of x minus your target value is equal to your error. So what this looks like in an example, so let's say that my bottle of pop is supposed to be 20 ounces, but it could be, let's say, half an ounce off. Okay, so the way I would set this up is that the absolute value of x minus 20 is equal to 0.5. You can also do inequalities here if you're trying to find a range. If you're trying to find the absolute highest and the absolute lowest, you would use an equal sign. And what we find out from here is that it could be as low as 19.5 or as high as 20.5. Alright, so you are buying a new computer. The table shows the prices in a store advertisement. You are willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your condition? So first thing we're going to have to do is we're going to have to find the mean price. So remember, to find the mean, it's the average. So we're going to add them all up and then divide by how many there are. So 890 plus 650 plus 660 plus 450 plus 725 plus 750 plus 370 plus 670 plus 650 plus 825. Alright, so our mean is equal to 6,640 divided by 1, 2, 3, 4, 5, 10. So our average is going to be $664. All right, so we want to be within an absolute deviation of at most $100. So this means 664 is our target. So the absolute value of x minus 664, at most 100, so it has to be less than or equal to 100. And now we have an absolute value inequality, so we can split it up. So x minus 664 is less than or equal to 100. And this is a less than problem, so it's going to be and x minus 664 is greater than or equal to negative 100. Go ahead and solve both of them. So x is less than or equal to 764, and solving over on this side, x is greater than or equal to 564. So what this looks like on a number line, here's 564, here's 764, close circle on both of them. It's an and they overlap, so it's going to be all the values in between. Notice that this is, you can do this a pretty intuitive way and say, oh, it's plus or minus 100. 664 plus or minus 100, that's okay too. Just know that you can write it using absolute values.